Welcome to this online tutorial on pure mathematics. Pure mathematics, and in particular, we are going to discuss UNEB 2023 marking guide. Question 1, proof by induction. 5 marks, section A, proof by induction. Don't forget to subscribe. This video is kindly suitable for students who are in senior 5 and senior 6, offering principal mathematics, not subsidiary. Proof by induction that this is equal to this. Now, the best way to approach this question is to first expand this sum. We are summing from r equals 1 up to n. So we substitute r equals 1, r equals 2 up to n. So if we substitute r equals 1, we shall get 1 squared. Then plus, substitute r equals 2, 2 squared, plus substitute r equals 3, 3 squared, plus up to r equals n. So this is equal to n plus 1 to n plus 1 over 6. We're going to prove that by induction. So we start. If n is equal to 1, if n is the first term, n stands for the number of terms. If n is one term, the left-hand side will be 1 squared, which is equal to 1. Then the right-hand side, which is n plus 1 to n plus 1 over 6. This is equal to, substitute n equals 1, 1 plus 1, 2 times 1 plus 1 over 6. So this becomes, this is 2 times 3 over 6. This is equal to 1. So left hand side is equal to right hand side, implying that the result holds for n equals 1. For n equals 1. Now, if n equals 2, if n is equal to 2, left hand side, n stands for number of terms. Left hand side, now we have 2 terms. The sum of 2 terms, left hand side, 1 squared plus 2 squared, and this is 1 plus 4, which is equal to 5. That is left hand side. Then right hand side, where there is n, you substitute 2, n plus 1 to n plus 1 over 6. This is equal to 2 to n plus 1, 2 times 2 plus 1 over 6. This is 2 times 3 times, this is 3, then 2 times 2, this dot means multiplication, 2 times 2, that is 4, plus 1, 5 over 6. So this 6 cancels out with 2 times 3. So we remain with our answer as 5. So left hand side is equal to right hand side, implying that the result holds for n equals 2. Now we proceed to the induction step. Assume that the result holds for n equals k. Assume that the result holds for n equals k. What shall we have if we assume that the result holds for n equals k? We shall have 1 squared plus 2 squared plus k squared equals k plus 1 2k plus 1 by 6. We have that by 6. Then we prove that it holds for n equals k plus 1. You assume that it holds for k, for n equals k, then you prove that it holds for n equals k plus 1. So we prove that the result holds for n equals k plus 1. So where there is n, kindly you substitute k plus 1. Substitute k plus 1. Substitute k plus 1. So we shall have, we want to prove that the result holds for n equals k plus 1, i.e., that is to say, we are supposed to show that 1 squared plus 2 squared plus k plus 1 squared, this is equal to k plus 1, where there is n. Look here, where there is n, I'm substituting. Where there is n, I'm substituting k plus 1. So this is k plus 1, which is k plus 2. Then this is 2, then k plus 1, which is 2k plus 1 plus 1. So this becomes 2k plus 2 plus 1, which is 2k plus 3. 2k plus 3. So here we shall have 2k plus 3 over 6. We prove that. We prove that. So before I wrap off this, we can look at how marks are supposed to be awarded for this question. So here we shall have B1 for n equals 1. Then for n equals 2, B1. Then this is B1 induction step. And this is this does not carry marks, but the next step is the one which is going to carry the method mark. So I think I should wrap off this. Kindly take note of this. So you suppose that the result holds for n equals k, then prove that the result holds for n equals k plus 1. K plus 1. So we are supposed to show this. The result holds for n equals k plus 1. So 1 squared plus 2 squared plus k plus 1 squared. This is the same as 1 squared plus 2 squared plus k squared plus k plus 1 squared. K plus 1 squared. Now we can substitute this because we know that. But 1 squared plus 2 squared plus k squared is equal to this sum. This sum is equal to k plus 1 2k plus 1 over 6. So where there is this sum here, we are going to substitute that. Therefore, we shall have 1 squared plus 2 squared plus k plus 1 squared. This is equal to, so where there is this sum, I substitute k plus 1, 2k plus 1 over 6, then plus k plus 1 squared. So we can get the LCM. We can get the LCM. A moment. So the LCM here is you can decide to first get the LCM, which is 6, or you can also factorize out k plus 1. K plus 1 is common. So we can put k plus 1 outside such that we remain here with k, 2k plus 1 over 6, then plus k plus 1. We have that. I have factorized out, this is outside, also this is one of the 2k plus 1s here is factored outside. So this is equal to k plus 1, then the LCM of what is inside is 6. The LCM is 6. So 6 divided by 6, that is 1 times that, we shall have k, 2k plus 1, then plus 6 by 1, we get 6 times that, 6k plus 1. 6k plus 1. Now we can open brackets. This is k plus 1, brackets, 2k squared plus k plus 6k plus 1 over 6. One next. Then I can proceed in this way. So this is equal to k plus 1 over 6. Observe that here I'm having a multiplication sign, so I can put this fraction 1 over 6 outside. So here I have 2k squared, then 6 plus k, that is 7k plus 1. So this becomes k plus 1 over 6. So I have to factorize this quadratic expression. 2k squared plus 7k plus 1. Observe that I need factors of 2, which when added, a moment, I think I made a mistake here somewhere. This is a 6, this is 6. Sorry. This is 6. Yeah, if you multiply. So this is 6. If you open brackets, this times this 6k, 6 times that, you obtain 6. So here I'm having a 6. So factors, we need factors of 2 times 6. 2 times 6 is 12. Factors of 12, which when added give 7. So those factors are what? Factors of 12, which when added give 7. I think they are 3 and 4. So here we are going to write 2k squared plus 4k plus 3k plus 6. This is actually equal to k plus 1 over 6. So I can group those two together, also this last pair together. So 2k is common, put it outside, so I will have k plus 2, then plus 3 here is common. 2k was here and also 2k was here. That's why 2k can be factored out. Also here, 3 is common. Put it outside, we shall have k plus 2. And this becomes k plus 1 over 6. Then 2k plus 3, k plus 2, k plus 2. k plus 2. So I think now we have the result. We are supposed to show this. You can go back. We were supposed to prove this result here. So we have that. So replacing n equals k plus 1. In simple terms, replacing k plus 1 with n. If we replace k plus 1 with n, what do we have? If we replace k plus 1 with 10, so with the n, so we shall have k plus 1 is n over 6. K plus 1 is n. K plus 1 is n. And here we shall have 2 k plus 1 plus 1. Let me hope you remember this expression when we substituted k plus 1 at first. So 2k plus 3 is the same as 2 multiplied with k plus 1 then plus 1. And also this last one is the same as k plus 1 plus 1. So we shall have our result 2 or n over 6, then 2 n plus 1 n plus 1 n plus 1. So I think this was the required result. Let me try to check the question. The question is having n plus 1, 2n plus 1 over 6. Yeah. Yeah, it's having that. So this is the required result. Now observe that on this question, much of the work is on this induction step, this step of adding k plus 1. So I can try to recap some few things. So from the other step of assuming that the result holds for n equals k, then you prove that the result holds for n equals k plus 1. So where there is n, you substitute k plus 1. So we shall have this, but this can be written as 1 squared plus 2 squared plus k squared then plus k plus 1 squared. Before reaching this term here, before reaching that term for k plus 1 squared, there is a term for k squared. Yeah, but we assumed that this sum was equal to something, but this sum is equal to something. So if we substitute this back, we shall have this, then plus k plus 1 squared. Then do some algebra of adding, factorizing, we will obtain the required result. Yeah. Now we can proceed to question 2. If a line y equals mx plus c is a tangent to that curve, show that c squared is equal to 4 plus 3m squared. So it's like a line touches this curve, and I think this curve is an ellipse. Yeah, it's an ellipse. So we have a line which touches. So the line intersects the curve. The line intersects the curve at a certain point. In simple terms, this is what we are having. Kind of an ellipse, then a line. It touches the tangent, touches the curve at a certain point. So they intersect in particular. So since they intersect, then we are going to substitute one in the other. So since y equals mx plus c, y equals mx plus c, we are going to substitute y equals mx plus c into 4x squared plus 3 squared is equal to 12. Why am I substituting? Simply because they intersect. So 4x squared, where there is y, I'm going to substitute something, then plus 3 where there is y, I'm substituting mx plus c, but squared is equal to 12. Observe that you can also substitute x. You can come here, make x the subject, then substitute it there. So let us try to simplify. This is 4x squared, then plus 3, open brackets here, m squared, x squared, plus 2c mx plus c squared is equal to 12. Is equal to 12. Open brackets, 4x squared plus 3m squared x squared plus 6c mx plus 3c squared is equal to 12. Is equal to 12. We can try to express that thing in terms of a quadratic equation. A quadratic equation is always in the form ax squared plus bx plus c equals 0. So we are going to group those terms which are having x squared, particularly this term and here. Put x squared outside because x squared is common in both of them. So if we put x squared outside, we shall have 4 plus 3m squared plus 3m squared, then plus 6c mx, then plus 3 squared minus 12 equals 12 equals 0. Minus 12 equals 0. So I've brought this 12, so at the right hand side I'll have a 0. So for tangents, observe this picture here. A tangent just touches the curve at one point. So at that point we are having repeated roots because it just touches it at one point. So we have repeated roots at that point. So for repeated roots, if this equation is to have repeated roots, in simple terms, this is the condition for tangents. You need not forget this condition. For tangents, b squared is equal to 4sc. So when we look at this is the general form of a quadratic equation. So look at this and this. Compare both of them. If we compare both of them, so where there is a is the coefficient of x squared. So the coefficient of x squared in this equation is 4 plus 3m squared. Then p is the coefficient of x. Coefficient of x in this form is 6cm. Then c is this last term, which is 3 squared minus 12. Now we can substitute here. B squared is equal to 4sc. So B is what? B is 6cm squared. That is B. This is equal to 4a, 4 plus 3m squared. C is 3c squared minus 12. Let us simplify this thing. Open brackets, we shall have 36c squared m squared is equal to 4. We are going to open brackets here. We shall have multiply 12c squared, this and this, 12c squared, then minus 48, then plus 9m squared c squared minus, then this times this, that is minus 36m squared. So we shall have 36 c squared m squared is equal to, open brackets here, open brackets 4 times 12, that is I think it's 48 c squared, 48c squared. Then here I'm having 48 times 4. 48 times 4, I have to do some algebra there. 48 times 4. So 48 times 4 is 192 minus 192. Then 4 times 9, that is 36m squared c squared, then minus 4 times 36. 4 times 36. 4 times 36. 144. Minus 144 m squared. You observe that some factors are common. Some factors are common. So if we bring this 36m squared, c squared, this term, this side, if we bring this term this side, they will cancel out. This side. So I will have 36 c squared m squared minus 36 c squared m squared. This is equal to 48 c squared minus 192 minus 192 minus 144 m squared minus 144 m squared. So what can we do? This is a 0. So this is a 0 equals 48 c squared minus 192 144 m squared. So we can bring these two terms this side. So basically, if we bring them this side, we shall have 48 c squared. And what shall we have? We shall have 192 plus 144 m squared. This is equal to 48 c squared. 48 c squared. I'll borrow these terms this side. So I can divide throughout by 48. 48. 48. 48. So if I divide throughout by 48, what shall I have? 48, 192 divided by 48, 192 divided by 48, I get 4. I'll get 4 plus 144 by 48, that is plus 3 m squared. This is equal to c squared. And I think that was the required result. Let me check. 4 squared 4. It's 4 plus 3m squared equals c squared. So fundamentally, that is the solution. So you will get 1 mark for substituting B1. You also get another mark for simplifying. Then you get for simplifying and expressing it in terms of a quadratic expression. Then you get method 1 mark for correct method of substitution. Then you also get another mark for correct simplification, then plus 1 mark for the answer. So that is it. Now we can proceed with the question 3. So question 3, we have that, but I think I'm losing light, but don't worry. Yeah, I think I'm going to make some few adjustments. The next question. So we have that, given that y equals e to the x cos 3x, show that this relation here, the second derivative minus twice the first derivative plus 10y is equal to 0. Let me make some few adjustments to increase on the brightness, but I'm going to proceed with that in the next tutorial.